Hello members, in this discussion we are going to look at a question that pertains to work done on an inclined plane. So we have a guiding question which says a rough surface is inclined at an angle theta to the horizontal. A body of mass m is pulled at a uniform speed at a distance x up the surface by a force acting along a line of greatest slope. The coefficient of friction between the body and the plane is nu. If the only resistance to motion is due to gravity and friction, show that the total work done on the body is mgx into sine theta plus nu cos theta. So first of all, we have to appreciate that this is a plane that is inclined and have a body moving on it. So this body is going to be under the action of a number of forces. So forces on the body. So one, we have the weight of the body, mg. Then we have one, the normal reaction, which we can call R. And this normal reaction depends on, of course, the friction force. So then we have again the friction force, and then this weight has components. Okay, we have the component of this weight that is acting along the plane, and also the one that is acting at some angle. So then we have the components. Maybe let us put it here, and its components. Then, of course, we have now the force that is moving the body. So let this be W equal to mg, that is the weight on the body. Then the normal reaction, let it be R, and let the frictional force F equal to nu R, because we know the frictional force and the normal reaction are related by this formula, whereby nu is the coefficient of friction between the plane and the body. Then let this force be P. Okay. So what we do, we are going to draw. Let this body be like this in the form of a particle, and the plane is at an angle theta with the horizontal. So we are going to indicate forces. So the forces acting, we said we have one, the force due to weight of the body. Then we said we have also the normal reaction, which is normal or perpendicular to the plane. Then we have a force that is pulling this body, and we have just called it P. Then we said this normal reaction is the one that is going to come about as a result of the friction that we have here. So when the body is moving up here, the friction force will act downwards along the plane, and this is our F. Then we said also there is a component of the weight that actually also gives the normal reaction, and that's what we call the W cos theta. Then the other force, which is the component of this W, is called W sin theta, which also acts along there in that direction. So this force is acting on the body, pulling it down, and is as a result of gravity, and that is due to the weight of this body. So if we look at the equilibrium of the plane, we shall find that if we talk about forces perpendicular to the plane, we have R, okay? We have R and W cos theta. So R is equal to W cos theta, because this is moving up, this is moving downwards. But so let's make this equation 1, and then we look at forces parallel to the plane. So forces parallel to the plane, we have P, we have F, we have W sine theta. So that means if I talk about balance, then at equilibrium P will equal to F plus W sine theta. But we know F is equal to mu R, okay? F is equal to mu R. Now, if F is equal to mu R, I substitute it in here, and my P will equal to mu R plus W sine theta. But we also know, W is equal to mg, okay, mass times acceleration due to gravity. But also from equation 1, R is equal to W cos theta. So what does that mean? Our P will equal to mu R, whereby mu is the coefficient of friction, times R. R is the same as W cos theta, plus W sine theta. But we said W is equal to mg. So what does that mean? Our P will equal to, I can factorize out that W, or I just put it, okay, mg cos theta plus mg sine theta, then I factorize out mg. So mg sine theta plus mu cos theta. Okay, that is P. Now, that is equation 2. We are told that the force acts on the body for a distance x. So what does that mean? This means that work done on the body by the force will be P times x. So the work done will therefore equal to P times x. But this P, we know it, so this is going to be mg, okay, into sine theta plus mu cos theta. We multiply this by what? By x. So the work done will equal to mg x into sine theta plus mu cos theta, and this is as required. So first of all, determine the forces that are acting on the body, then look at the equilibrium of the body by looking at forces that are perpendicular to the plane, and look at forces that are parallel to the plane. Then give the definition of work done, which is the product of force and distance, and then you will be able to attain that expression.